Now let's see the part 3 of ionic equilibrium. Ionic equilibrium. So now see the first question, number 10. It is asked in 2008. The value of Kp1 and Kp2 for the reaction. So when X dissociate, it forms Y plus Z. And similarly, A dissociate, it forms 2B. Right. So are in the ratio. So Kp1 by Kp2 ratio is given, that is 9:1. Degree of dissociation of X and B. X and A will be equal. So degree of dissociation of X is equal to degree of dissociation of A are equal. They are given in the question. Total pressure at the equilibrium are in the ratio. So it is asking about the total pressure of X and total pressure of A. How much it will be. Right. So see the explanation. Whole explanation. Good question it is. So see, I will explain you step by step. Suppose initially X we have taken as 1, right? And it is dissociating into Y plus Z. So initial value of X is 1. This is 0, 0. So at equilibrium, it will become 1 minus alpha, alpha and alpha. This is at initial position. Initial. It is at equilibrium. Right. So now find total number of moles. Total number of moles is equal to 1 minus alpha plus alpha plus alpha. Then it will become 1 plus alpha, right? So this is the total number of moles. So see the concentration of X first. So concentration of X will become 1 minus alpha divided by total number of moles, right? Next is concentration of Y is equal to alpha upon 1 plus alpha. Concentration of Z is equal to alpha by 1 plus alpha, right? So write the equilibrium constant at partial pressure P1. So it will be concentration of X, right? No, here it comes first, right? This is the product, right? So product concentration comes first. So it will become, this is your product, this is your reactant. So then concentration of Y into concentration of Z divided by concentration of X. In the partial pressure form, you have to write it. So now put the value of Y. So it will be what? Alpha by 1 plus alpha into P1, right? Initial product, that is P1. Similarly for right Z, so it will be alpha upon 1 plus alpha into P2, right? Divided by concentration of X. So it will be 1 minus alpha upon 1 plus alpha, right? Into concentration written, that is, and this is partial pressure P1. Now please arrange Kp1 now. So you can cancel this P1 with this P1. 1 plus alpha will cancel. So write the remaining one. So it will become alpha square P1, right? So this is your P1 again, not P2. That is, so it is alpha square P1 divided by 1 plus alpha into 1 minus alpha, right? So you can observe here, this is A plus B into 1 minus B. So see in the next slide, Kp1 will become alpha square by 1 minus alpha square. I have used the here identities as A plus B into A minus B as A square minus B square, right? So this is the Kp1. Here pressure P1 is also there, right? So this is your Kp1. Now see the, for the case 2, when A dissociate into 2B. So it will become initially at 1. This is 0. This is at equilibrium. So it will become 1 minus alpha and this will become 2 alpha. Right. So total number of moles. Total number of moles is equal to 1 minus alpha plus 2 alpha. Right. Here we have added moles of A plus moles of B. Then it will become 1 plus alpha. Right. Similarly, now find for the concentration of A. Right. Concentration of A will be concentration 1 minus alpha divided by total moles. Right. Similarly, for B concentration, it will be what? 2 alpha divided by total number of moles. Understood? Now write the Kp2, equilibrium constant at partial pressure 2. So it will be concentration of B raised to 2 divided by concentration of A raised to 1. Now put the value in the pressure form. So here when we write in pressure form, then it will become P2 square divided by P1, right? Because its coefficient is 1. That's why its power will be 1 only. Right? After putting the value, you will get 2 alpha by 1 plus alpha square into P2 raised to 2 divided by concentration of A, that is 1 minus alpha divided by 1 plus alpha into P1. Now arrange this equation, then it will become P1. This will be P2, right? Because we are finding the equilibrium constant P2. So this P2 and this P2 will get cancelled. 1 alpha and this 1 plus alpha will get cancelled. So it will become 4 alpha square divided by 1 plus alpha will be remaining in the first part, right? And denominator will become 1 minus alpha. So again Kp2 will be equal to 4 alpha square divided by, this is again A plus B into A minus B. So it will be what? It will be 1 minus alpha square, right? We have used the identities, that is A square minus B square. So this is your Kp2. Right, now divide Kp1 by Kp2. So this is your equation 1, this is your equation 2. Divide now. Here P2 is remaining, right? So write here P2 also. So I will divide now equation 1 by 2 in the next slide. So please watch that one. So dividing equation 1 and 2, dividing 1 and 2, you will get Kp1 divided by Kp2. So Kp1 value is what? That is alpha square P1 divided by 1 minus alpha square. 1 minus alpha square, right? Divided by Kp2 value. So write here Kp2 value, that is 4 alpha square divided by 1 minus alpha square into P2, right? So here this will be cancelled by this, right? This alpha square will get cancelled with this. So remaining is P1 by what? P1 by 4 times of P2, right? Is equal to Kp1 divided by Kp2. So P1 by 4 times of P2 is given as 9 upon 1. 9 ratio 1, it is already given. Now arrange, you have to find P1 by P2. So P1 by P2, let it be remaining here and multiply this 4 with this 9. So it will 9 into 4 by 1. So it will be 36 upon 1 is equal to P1 by P2. Right. So this is the relation between pressure 1 with the pressure 2. That will become 36 ratio 1. So please write the whole explanation. Very important question. Now see the question number 11. Dissociation equilibrium of gas AB2 is represented as, it is 2AB2 balancing. After balancing, it becomes 2AB2 dissociate into 2AB plus B2. Right, so degree of dissociation is X. So here alpha is X. Alpha means degree of dissociation, and is a small compared to 1, right? And is very small compared to 1. The expression relation of the degree of dissociation with equilibrium constant Kp and total pressure P, it is asking about. So it is asked in again 2008. So now see the explanation. So initially it is of 2 mole, right? It is coefficient is 2, that's why, right? It will not dissociated, so it will be 0, 0. So it is at the initial position only, right? So when at equilibrium reached at equilibrium, then it will become 2 into 1 minus x. We are not using here alpha, because instead of alpha we have to use here x. Then it will become 2x, it will be x. So total number of moles will be equal to 2x plus x plus 2 into 1 minus x. So it will become 3x plus 2 minus 2x. So it will be x plus 2, right? So now write the equilibrium constant pressure P is equal to, right, this is equilibrium constant at partial pressure P. So it will be the concentration, partial pressure of AB raised to 2. Why 2? It is coefficient is 2, that's why. Into partial pressure of B2. So it will be partial pressure of B2 raised to 1. Similarly here, partial pressure of AB2 raised to 2. Now put the value. So it will be Kp is equal to, as we know the value of AB is 2x. So it will be 2x raised to 2. And write the P form also, into P square divided by total number of moles. Total number of moles we have got x plus 2. So it will be also squared, because coefficient is 2 now, that's why we are squaring. Now write for partial pressure of B2. So it will be x into P2. P2 no P. Only P, because it is coefficient 1. It is a square. Divided by x plus 2. Right, divided by partial pressure of AB2. So it will be how much? It will be 2 into 1 minus x divided by total number of moles. So it will be x plus 2 raised to 2 whole twice, right? So it will be Kp is equal to 4x square P square into x into P divided by x plus 2 whole square, right, into x plus 2. So write this part also. So after squaring, then it will become 4 into 1 minus alpha whole square divided by x plus 2 whole square, right? This is multiply with this one, and this will be this denominator will be coming out upward. So it will be x plus 2 raised to square, and here pressure will be coming out, right? So it will be here P square. So write here also P square. Now cancel the part which is matching. So it will be cancelled with P square. Next, x plus 2 whole square will be cancelled with this one. Next part. This is 4, right? So this 4 and this 4 will get cancelled. So Kp is equal to x into P divided by x plus 2. Right. So remaining parts are x square is also there, right? So here x square. This part, this, and these are remaining, right? And 1 minus alpha is also remaining. So write here 1 minus x whole square. Is it clear to here up to this point? Now see.
Yes, sir.
So what will I will do here? I will assume something. As I have told earlier that when x plus 2, so alpha is very small, right? So it will be equal to 2. When we consider x as 0, then it will be equal to 2. Similarly, for 1 minus x, it will be equal to 1. So put here value, then it will become x into x square will be, that is x cube into p divided by x plus 2 can be written as what? It will be 2 into 1 minus alpha square will become 1, right? So this is the value you have got. So it will be x cube p divided by 2. That is your equilibrium constant, right? So you have to just find the x value. So see in the next slide. So it will be Kp we have got as x cube into p divided by 2 into 1, right? So x cube will be 2 Kp divided by p. So x will be the cube root of 2 Kp upon p. So this will be the answer for x. So write the explanation.